Welcome to AP Podcast 14.3. This is on the pH scale. Now, you've heard about pH balance for a woman, and we know about things that are acidic and basic. And what we're going to do is try and put that acidic and basic thing into a number that we can easily understand. And that's what the pH scale is. And so here's a nice little formula. pH equals the negative log of the concentration of H. Now, this scale is a logarithmic scale. So what that means is that every increase by 1, so for example, if I go from a pH of 3 to a pH of 4, you get an increase by tenfold. And a pH of 4 to pH 5 is another 10, and so on. So it's this logarithmic scale, exponential growth, that kind of thing. So all we do with something like this is we take a concentration. Let's imagine I had an H concentration of 1 times 10 to the minus 6. All right, I put that in my calculator and I hit the log button. And when I do that, I get a value of negative 6. But that's what this negative sign is about. So that allows me to just ignore that negative sign, right? Two negatives make a positive, and so I get a pH of 6. Now, the reason we use this scale is because the concentrations for most of the acidic and basic solutions we're going to deal with is usually very small. And so by using the scale, it allows us the number to change a decent amount so we can tell the difference between small changes. And then, as you can see in this bullet, as the pH decreases, the H constant increases. So if I had a pH of 3, right, versus a pH of 4, this would have this one right here would have a greater H plus concentration. All right. Now, one thing about significant figures, I know you guys are sick of significant figures, but this pops up every once in a while, so we want to make sure we've got it. Only the digit after the decimal place of the pH are significant. In other words, if I write out that I got a pH of 8.00, this number has two significant figures. Where do you get that? Well, you look at your original value. 1.0 times 10 to the 8th. That's got two significant figures, therefore I'm going to have two decimal places. I can tell you honestly, it doesn't pop up very often, but it's just kind of good to know that and have that kind of in the back of your mind. All right, two other things we can do. Let's say we know the concentration of the OH. Well, if we know the concentration of the OH, we could find the POH. All right, and there's a lot of debate what this P means, and we'll talk about it in class, but the things I've read in the journal articles I've seen, nobody really tends to agree. So we'll just leave it at that. And then also, if you have a value of K, you take the negative log of that, you'll get the pKa. And why that's important will become a lot more obvious to you as we spend more time doing acid and base problems, especially with equilibrium. So let's just get a good feel for what are the relationships between pH and POH and all that stuff. And here we have a few things that we know. You guys know that the Kw, the equilibrium constant for K, is dependent upon the concentration of H plus OH. And if you remember, that equaled 1 times 10 to the minus 14th for water, right? Well, if I take the log of Kw, I get the negative log of that concentration. Excuse me. And then I could distribute that to give me the log of the H concentration plus the negative log of the OH concentration. And that can further, with a little bit of algebra, be manipulated to the pKw equals the pH plus the POH, and that value is going to always equal 14. Now, why that's important is because let's say I have a pH of 3, all right? Well, if I know the pH and the POH have to add up to 14, and you saw a question, what would be the POH? Well, your answer would be 11, right? So it becomes a very useful tool in knowing that. So it's important that you understand that the pH plus the POH equals 14, and the pKw equals 14. Now, why does it? Well, think about it up here, right? 1 times 10. You go ahead and hit the log of that, negative log of that, you'll get 14, all right? So what that does is that allows us to find any of the 4 common things that you get asked to find for pH and OH. It allows us to find any one of these if we know Well, it allows us to find 3 if we know any one of them. And of course, you'll be asked to do that. You know they're going to ask you to do that. And so we'll do a couple practices uh, where we show our skills there. Now let's look at a kind of an everyday skill. This is kind of a neat diagram I have. And this just shows you the pH of some common things. And notice that our blood right here is just a little bit above 7. Pure water is at 7. So our blood is just a little bit basic. And that's super important. And our blood has to stay right around this pH range right here, or we have some medical conditions. And I'll talk about what happens when it gets a little bit lower, a little bit higher later. But here's some common things. Ammonia, look at that. That's got a pH of 12. And NaOH, which you guys are very, very familiar with, that has a pH of 14. Look at our strong acid. Ooh, HCl is 1. And then here's our stomach acid, which is just a diluted form of HCl. That's at a pH of 2. There's lemon juice and there's vinegar. Now, every once in a while, we'll get a problem where the pH will be lower than 1, and you can actually have a negative number. Don't freak out. It's not some anomaly, but it does happen. If you have a really concentrated, strong acid, you can get a pH below 1. But we don't usually deal with that, but I want you to be aware of it in case you see it. Now, just again as another diagram, if you want to, I wouldn't write this down, but this just kind of gives you an idea of the range of what's going on in case you had to do this in your head. And I will say this, there are times when you'll do a multiple choice question on an AP test where you don't have your calculator, and they'll expect you to know this. So look at this. 1 times 10 to the minus 1 is a pH of 1. Okay, 1 times 10 to the minus 11th is a pH of 11. And so really, if you think about this exponent right here, all right, you can turn that into the pH just by, mental math, I guess, so to speak. All right, and then so let's move on to some practicing. All right, now what I want you to do is to find the pH and the pOH for each solution at 25 degrees Celsius. Go ahead and take your time, write it out. I'll put my answers up, and then we'll see if you got what I. Alright, so did you get those answers? Well, if you didn't, this is what I would do. Okay, now there's a couple ways you can do this. You can always try and find the OH concentration, or the H concentration, but what I did with this is I just took the negative log of this, I got 3, and then I know that these two values have to add up to 14, so pH equals 11. Now if you put 1 into you hit the negative log of 1, that equals 0, and that might be something you already know. So the pH is 0, the pOH is 14. And then on this one, again, just negative log of 2.5 times 10 to the minus second, I get 1.6. And the difference between that one and 14 is 12.4. So there you go. Hopefully that worked out. Let's try another one. Pause the video. You know how it goes. See if you can find the concentrations there. But in fact, what I'd like you to do is just do these two. Do the first one, this one, and the third one. We don't need to do that second one, unless you want practice for funsies. Alright, so did you get these answers? And if not, let's just go over a little bit of what I did here. Okay, the first thing I did was if I want to find the concentration of H+, I took that 3.2 and I used my 10x key. Alright, you've got a 10x key in your calculator somewhere. So I hit negative 3.2, 10x, and it gave me this value right here. Alright, now once I know the H concentration, since I know that the H concentration plus the OH concentration, or pardon me, times, has to equal 1 times 10 to the negative 14th, I went ahead and took that number, divided it into 1 times 10 to the negative 14th, and I got this value. Right? And again, that's what's very useful about knowing that KW is always going to equal 1 times 10 to the minus 14th. So I get that my OH value that way. Now with this way, same thing. I did kind of the opposite though. With the POH, I again used my 10x, so I hit negative. I put negative 9.6, 10x key, and I got this value. And then I divided that number into the 1 times 10 to the minus 14th, and I got 4.0 times 10 to the negative 5th. So there you go. That's how you would get those answers. One last practice, and then we'll wrap this up. Alright, so there are the answers for that one. Now, if you didn't get these, this is definitely something you want to bring up tomorrow when we go over this. Other than that, we'll see you next time, and hopefully this made sense to you.